Good day, ladies and gents. Today we are going to be doing Unit 5 Study Guide. And here we go. All right, so first of all, we're going to find the sum of the interior angles of a 35 gon. All right, so if we look at our hot topics, we're just going to follow these steps right here. Step 1, is it interior or exterior? They said interior. Is it sum or regular? Sum. All right, and then write out the entire equation. So we have sum of the interior is n minus 2 times 180. So a lot of people accidentally do n minus 2 times 180. That's not right. No, no, no. You have to write the left side as well. So equals sum of the interior. So sum of the interior equals n minus 2 times 180. All right. And then I'll get out my calculator here. All right. So, and they said 35 gon. So we're going to plug in the number of sides. So that is 35 minus 2 times 180. All right. So in our calculator, we're going to do 35 minus 2 equals, and then we're going to multiply by 180. And we get 5940. And that is the sum of the interior. And that's what they were looking for. So that is your final answer. Excellent. All right, let's keep going. All right, next part. All right, so following the same steps that we just said a second ago, please ignore my calculator. Okay, so we have, is it interior, exterior? So they said interior angles, and they said the word sum is this. All right, how many sides? So we're looking for the number of sides. So sum of the interior, that's what we're talking about again. So sum of the interior equals n minus 2 times 180. So if we have that, and we have to write out the entire equation. Now, did they give us the number of sides or did they give us the angle? They gave us the angle, and that is the angle right here. So 3780 is equal to n minus 2 times 180. Now, there's two ways how to do this. One way how to do this is just to keep plugging in numbers in for n and seeing what works. So if I have so 3 sides didn't work, 4 sides didn't work. I'm trying to get 3780. So we just keep plugging numbers in to see what works. Nope. So I'm going to skip around even a little more. So let's do 10. All right, I'm getting a little closer. How about 27? Okay, that's a little too much. How about 25? Oops, still a little too big. How about 20? All right, so it's somewhere between 20 and 25. I'm just plugging in numbers randomly until I get the right number. 21, 22, I'm getting closer. 23, that's the one. So I kept plugging numbers in for n until I got the right answer, and the answer was n has to be 23. So that's one way how to do this. The other way is actually mathematically. All right, so if I zoom in a little bit. All right, so now I know the answer is 23. That is the answer. N has to be 23. So I'm going to show how that works. So if I distribute this, I ran out of room, so I'll put it up here. If I distribute, so I get 3780. If I distribute here, that is 180n. And distribute here, that's minus 360. Oops, ran out of room, sorry. All right, we're going to add 360 to both sides. And when I put that in the calculator, 3780 plus that 360, I get 4140 equals 180n. Divide by 180 on both sides. If I divide by 180, I pop out with 23 is equal to n. And that was the answer. So that's two different ways how to do it. Both are totally fine with me. All right, so as long as you have this beginning equation right here and you have your final answer, I'm totally happy with that. All right, next part, number 3. All right, so same steps as before. So follow your same steps. Okay, are these interior angles or exterior? So they're inside, so that is interior. And is it sum or regular? Now remember, regular means that they're all the same. So are these all the same? No. So they're not regular. So regular? Nope. So if they can't be regular, it has to be sum. All right, so it is interior and sum, and the only thing that has both interior and sum is right here. So sum of the interior equals n minus 2 times 180. All right, so let's write out the whole equation. So sum of the interior equals n minus 2 times 180. Okay, so I'm going to add all these together. I'm going to start here. I'm going to show my calculator so you can see what I'm thinking. All right, so I'm going to start here and I'm going to add up all my x's. So we have 8, so that's 8x plus, there's no x here, so that's 0, plus 10, plus 0x, plus 9x, plus 7x, plus 0x, plus 9x. Oh, and there, I landed on there. And there's supposed to be 1, 2, 3, 4, 5, 6, 7, 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. So I got all of them, and I got 43. So, so sum of the interior, so that's 43x. And then we're going to add up all of our numbers. So let's just leave that up there. All right, so starting at this dot, we're going to go 15 plus that 139 plus negative 11 plus 121 plus negative 17 plus 6 plus 153 plus negative 14, and I made it back home. And that's 1, 2, 3, 4, 5, 6, 7, 8. And I did say there were 8. So that is a positive 392 is equal to, now n, how many sides were there? 1, 2, 3, 4, 5, 6, 7, 8. So we said 8 earlier. So in my calculator, I'm doing 8 minus 2 equals, and then multiply by 180. So this side is really 1080. Okay, and then we're going to just solve like normal. So I'm going to subtract 392 from both sides. So 1080, subtracting 392 from both sides, and I get 43x equals 688. And then I'm going to divide both sides by 43. So 688 divided by 43. I ran out of room, so I'll put it up here, and I have x would equal 16. So we have x is 16. Awesome. So now that we know that x is 16, we're going to take that and we're going to plug it into these. Just double check. Or if they ask me for all these different ones, but nicely, all they asked is for x, so we could stop right there. So that is our answer. I know for a fact that all of this adds up to 1080. So if I plug all these things in, if I plugged in x, I just want to make sure all these better add up to this number. If they don't, I know I messed up. But that is the correct answer, so let's just move on. All right, so this one, number 4. All right, so number 4, following our same steps, is this interior, exterior? Okay, so this is on the inside. So it's interior. Is it regular or sum? Now, because it is all equal, all the sides are equal, all the angles are equal, so all the sides are equal, so this would be regular. So interior, regular, so that's regular interior. So the equation for that, and let's put this out here again. I noticed that a bunch of people thought that this is an exponent, so these are separated. Sorry about that. So this goes up to this one, and this one is totally separate from that. All right, regular interior is n minus 2 times 180 all over n. So regular interior equals n minus 2 times 180 all over n. Now how many, so regular interior, so what was our interior angle? That's this. So that is 7x plus 31 is equal to, now how many sides? There's 5. So the n is really a 5. So what we're going to, marked out the wrong thing. All right, so we're going to do 5 minus 2 times 180. So all of this adds up to 540, but there's 5 of them, so each one of these is 108. So altogether, that is 540. Each individual angle is 108. And now you just solve like normal. Subtract 31 from both sides. 108 minus 31. You get 77. 7x is equal to 77. Divide by 7, and you got x equals 11. And then just to double check, you could plug it back in, but they just wanted x, and that is the correct answer. And we're just moving on. Sweet. All right, number 5. All right, so number 5. So still following the same steps as before. All right, so is this interior, exterior. This is exterior. Is it sum or regular? They said the word regular. All right, and they're looking for the number of sides. And they said that the angle is 24. All right, so let's write out the equation. So this is regular exterior. So regular exterior. And that equation, let's see here, just fold this down a little bit. All right, so regular exterior is equal to 360 over n. All right, so now this is the angle. So that's the regular exterior angle. So that's 24 is equal to 360 over n, and that's what you're looking for. All right, so that we have 24 equals 360 over n. If you put 24 over 1 and you just cross product. So the n you're trying to get rid of because you don't want it as a denominator. So these two multiply together. You can multiply n on the other side. That's 24n equals, and then 360 times 1. Okay. So we have 24n equals 360. We're going to divide both sides by 24. And you get n equals, so 360 divided by 24. And you get n equals 15. And that's how many sides you have, 15. Now, some people might accidentally put the 24 down here. This is just one of those problems where if you put it in the wrong spot, you just happen to get the right number, but that's not always going to work. So make sure you do this the correct way so you don't mess up. Awesome. All right, number 6. What is the measure of the exterior angle of a regular nonagon? All right, so that is regular exterior equals 360 over n. Okay, now regular, so we're looking for the angle. 360 over n. N, how many sides is that? Nonagon means 9. So it has 9 sides. So regular exterior equals 360 over 9. 360 divided by 9, and you get that the angle is 40. And that's your answer, 40. All right, number 7. Okay, are these interior or exterior? Now, are these inside the shape or outside the shape? In this case, these are each outside the shape. So we have, so these are exterior. Is this sum or regular? Are these all the same? They're not all the same, so they're not regular. So if they're not regular, then it has to be sum, right? So we have sum of the exterior, or SE, is equal to, and if you look at the equation, sum of the exterior is just 360. So 360. So we know that all of these are going to add up to 360. So I'm going to put a dot right here so I know where to start. And I'm going to put this in my calculator. Zoom out a little bit so you can see my calculator. All right. So starting here, I'm going to add up all my x's. 7 plus 9 plus 4. We pop out with 20x. Okay, now I'm going to add up all my numbers. We have negative 2 plus negative 31 plus 33. Ooh, that's plus 0. Nice. Equals 360. All right, if I subtract 0, that doesn't do anything. So it's just 20x equals 360. Okay, next thing we're going to do is divide both sides by 20. Okay, 360 divided by 20, and you pop out with x equals 8. Okay, now, they were nice enough to only ask us for x, but you know me, I'm a tricky bugger. Things I would totally pull on you. I would totally ask you for an angle in here. I would totally do that to you. So let's go ahead and go a step further. So technically we're done. They only want x. But you know me, so let's go ahead and plug this in. So if I plug this into here, so 4 times 8 plus 33, this angle, so this angle is this angle out here, and you want to cross this out and put it as close to where it's supposed to go. So I'm going to put this 65 right here. All right, let's do this one up here. So 7 times 8, subtract 2, that would be 54. And let's do this one. 9 times 8 minus 31, and that would be 41. Okay, so if I asked you for, now technically we're done, but these are extra things that we're doing here. If I asked you for angle, CED. If I ask you for CED. Now, the center letter is E right here. That's awesome. But I said CED. So put your finger at what angle we're looking at, and I would either be asking you for the inside, the outside, or the whole shebang. They said CED. So if I said CED, which angle do you think I'm talking about? CED. It's definitely at E, but is it the top of E, the bottom of E, or the whole thing? CED, that would be this one right here. We don't know what that is. However, we do know that it makes a rainbow of a straight line, and that makes 180. So altogether, this makes 180. So 180 minus that 65, this thing will be 115. So that'd be 115. And that would be the answer that I might be looking for. And you know me, I'm tricky, so be careful with that. Sweet. All right, let's keep going. All right, number 8. Okay, now we're talking about these. Okay, so these rules right here, they said this is a parallelogram. So because it's a parallelogram, let's look at the rules. See these two angles? What do you think they do? All right, now just looking at them, see how they're both obtuse? I really think that those are equal. And you're right, because opposite angles, where is it? Opposite angles are congruent. This angle is equal to this angle. So these are equal, so let's solve that. 8x plus 17 is equal to 12x minus 39. And now you just solve for x. I'm going to subtract 12x from both sides because I personally just like having x on the left side. So 8 minus 12, we get negative 4x. And then plus 17 is equal to, and that's still negative 39. I'll zoom in a little more. All right, we're going to subtract 17 from both sides because we're trying to get away from the x. This cross out, I ran out of room, so I'll put it up here. Negative 4x equals negative 39 minus that 17, that is negative 5, 6. We're going to divide both sides by that negative 4, and you get x equals a positive 14. And every time you find x, you're always supposed to plug it back in for multiple reasons. One, to check yourself, but also to be prepared no matter what they ask you. Because remember, I'm tricky. So let's plug this back in. All right, this would be 8 times 14. Oops, I wasn't finished. 8 times 14 plus that 17. We pop out with 1, 2, 9. And then 12 times 14 minus 39. And that's also 1, 2, 9. And were they supposed to be equal? Yeah, they were. So I feel really good about that. Okay, in addition to that, so I feel good about this. I checked myself. Now, what did they ask for? They asked for n. Ooh, they want this angle. Okay, so what do we know about these angles? Well, because these were parallel, so this is parallel to this, and this is parallel to this. So parallel lines, you can make the same color. Now, the thing is, blue, so blue and yellow. The cool thing about highlighting the same colors, all the blue, yellow, obtuse angles will all be equal. All the blue, yellow, acute angles will all be equal. So you see how this is blue and yellow, and that's obtuse. It's bigger than 90 degrees. Look at that. Blue and yellow, that's obtuse. That's also 90 degrees. So, and here's the thing: the obtuse and the acute add up to 180. So if this is 129, the other one has to be 51. And so blue, yellow, acute would also be 51. Now, so what was n? The answer is 51. And that's it. Fabulous. Okay, this one right here. All right, so we know this parallelogram. We know that this is parallel to this. We also know this is parallel to this. So this one right here, this is acute, this is obtuse. So are they the same or different? They're different, so that means that they add up to 180, because obtuse and acute of the same colors would add up to 180. So these two add up to 180. So we have 5x minus 6 plus that 14x minus 4 equals 180. Now you just solve for it, right? All right, 5x and 14x, that makes 19x. Negative 6 and negative 4 make a negative 10 is equal to 180. Add 10 to both sides. 19x equals 190. Divide by 19. X equals 10. What should you always do after you find x? Plug it back in. So I'm going to grab out my calculator. I'll zoom out a little bit so you can see what I'm doing. All right, so plug that in. 5 times 10 minus 6. Now, the arrow goes here, so let's cross this out and put it where it's supposed to go. It's supposed to go right here. That's 44. This one here, 14 times 10 minus 4. Cross that out. The arrow goes here, so this would be 136. Okay, so all of the blue, yellow, acute would also be 44. So here is, this is acute, so this is 44, and this right here is 136. Lovely. All right, fantabulous. Okay, so we have those, and then they said what was R. So R was 136, and that was our final answer. All right. Okay, this one down here. Let's see. So this one right here, okay, so it said it was a rectangle. So we have our rectangle rules. So a rectangle is all the parallelogram rules work, but on top of that, they have these 3 additional rules. And one of them is all 4 of these are going to be equal to each other. All diagonal parts are congruent. So this, and this all are equal to each other. So let's just label stuff first. They said PR. Okay, that's the whole shebang. So I can't really write it in here, so I make this line. That is 9x plus 1. They said QS. Q to S, that's the whole shebang again. I'll put it right here. That is 13x minus 11. And they want TR, so we'll find that later. All right, what's awesome about this is we know that that was triple, triple, because I'm thinking about this idea. Triple, triple. That's triple, triple. That means they're equal, which it says diagonals are congruent. So all of this equals all of this. So matching all of this equals all this. So we can set those equal and solve. So 13x minus 11 is equal to 9x plus 1. Subtract 9x. 9, 10, 11, 12, 13, 14, 9, 10, 11, 12, 13. So that's 4x minus 11 is equal to 1. Add 11. We get 4x is equal to 12. Divide by 4. X equals 3. And now we're going to plug that back in just to double check we're correct and to be prepared no matter what they ask us. So if we plug this back in, we have 13 times that 3 we said, minus 11. So this should be 28. Let's plug it into the other one. That should also be 28, but we're not sure yet. It is, so I feel really good about that. Okay, so this is 28 and that's 28. And then so if we want TR, so we know that all these little parts are equal. So if this is 28, 28 divided by 2, this would be 14, that would be 14. This would be 14, this would be 14. If I match my picture, see how it's triple, triple? Yeah, all these would be equal. And they want a TR, and TR would be 14, would be my final answer right there. Sweet. Okay, this one right here, they say it's a rhombus. So let's label everything. They said A to D. So AD, that is 4x plus 2. DC, that is 7x minus 13. And BD, that's the whole shebang, so I'll write that here. That is 34. And they want A to E, so we'll find that later. Okay, so this is a rhombus. Now, a rhombus is a knocked over square. So that means that all of these sides out here are equal to each other. That's pretty simple. So these two are equal, definitely. And if you didn't notice that, match to your picture. So if we match to our picture, and I'm turning my paper until it looks like the one I have this side and this side. And you see how this has a double and this has a double? That means that they're equal to each other. Perfect. So we're going to set those equal to each other. So 4x plus 2 is equal to 7x minus 13. Subtract 7x. We have negative 3x plus 2 is equal to negative 13. Subtract 2. Negative 3x is equal to negative 15. Divide by negative 3. X equals a positive 5. Okay, as soon as you find that, you always plug it back in for multiple reasons. 4 times that 5 plus 2, this turns into a 22. 7 times 5 minus 13. Yay, that's also 22. So this is 22, and that's 22, 22, 22. Let's see, what else? They wanted A to E, so we still want this. What do we do now? Okay, so, what could we possibly do? Well, this is 34. 34 divided by 2, I would get 17. So this is 17, that's 17. Now, are these equal to each other? I don't know. Let's see. Does this equal that? Yeah, so this definitely equals that, right? So if I put a single there and single there, and then, but these are equal to each other, but this does not equal that, right? So these two are not equal to each other here. So how am I going to find this? Well, the best way to do that is the Pythagorean theorem. So anytime you're looking for a missing side, and you can't find it right off the bat, you probably have the Pythagorean theorem, and here are the two possible options that's going to happen. So in this case, right here is the right triangle. Now I ran out of room, so I'm going to put it down here at the bottom here. So let's see, we have this triangle where, just zoom out a little bit. So this is 17. This is the side I'm looking for, and this side right here is 22. All right, so I'm gonna call that X. All right, and we're just Pythagorean theorem. So put your finger on the right angle. The two sides you're touching are A and B. So 17 squared plus X squared is equal to the one side you're not touching, which is 22, which is C in this case. All right, so 17 squared, which is 289, plus X squared we're stuck with, equals 22 squared. We get 484. We're going to subtract 289 from both sides. We get X squared is equal to 195. X is equal to the square root of 195. Square root of 195. And we get a big long decimal. This big long decimal. And did they say anything about rounding? In this case, they did not. So I'm just going to just double checking some stuff. 11. Dun, 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 dun. Double checking, you're the one. Okay, yeah, so we're going to go two decimal places. We get X equals 13.96. And that will be our final answer. All right, perfect. So that's the answer for number 11. Sorry, we ran out of room on that one. Okay, number 12. All right, so number 12, and if you should put it back in the picture and make sure everything worked out, that was 13.96, 13.96. Yeah, this looks legit. All right, over here. This one, we have MN. So this right here is 20. And they say JL, that's the whole shebang. That is 26. Let's see, it's a rhombus. So if this is 20, this would also be 20. If all this is 26, this would be 13 and 13. And what are they looking for? JL. Oh, sorry, JK. They're looking for this. So do you see the right angle, the right triangle right here? So you're just in Pythagorean theorem again. So focusing on that Pythagorean theorem, we have 13 squared plus 20 squared equals, in this case, X squared. 13 squared, that is 169. 20 squared, that is 400. And we're stuck with X squared. Add those two together. We get 569 equals X squared. Okay, so square root of 569 is equal to the X. So square root of 569, and I get 23.85 roughly equals X. All right, 12. Yep. Now, things that might happen that I would totally pull on you. So for instance, this right here, so just problem just like it. If they gave you all these, right? So if all this was 26.2, and all this was 16.6, and this was 20.4. Okay, if this is 20.4, just divide by 2. This is just an example, guys. Just an example. All right, so you just divide that by 2. Boom, 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 boom. Okay, now I want this. So you just give me the perimeter. Oh, wait, you mean all I have to do is add up all the sides? I didn't even have to do Pythagorean theorem. Boom. That was so simple. Yeah, so that is another possibility of things that could happen. So this was just a random example. All right. And then there's this problem. Okay, number 13. Okay. Okay, so they said this angle, so E. When I put, so I'll put this yellow here. So I'm talking about E right here. So that's either the top, the bottom, or the whole shebang. They said D, E, G. So it's definitely here, or the whole shebang. It's one of these, but they said D, E, G. So that's definitely this one up here. So that's 4x minus 5. Now they said G on this one, F, G, E. So FGE, so it's the top, bottom of the whole shebang. FGE, that would be the bottom. That's 6x minus 21. Okay, we want to find x. If I do my z, boop, 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 I know these two angles are equal because of alternate interior angles. So 4x minus 5 is equal to 6x minus 21. Just solve. Subtract 6x from both sides. Negative 2x minus 1 equals negative 21. Add 5. Negative 21 plus 5, we get negative 16. So negative 2x is equal to negative 16. Divide both sides by negative 2, and we get x equals 8. So let's plug that back in to double check everything. So 4 times that 8 minus 5, this angle is really 27. 6 times 8 minus 21, yes, that's also 27. I feel really good about this. And now they wanted G. Now, you know me, I'm a tricky bugger. I am totally the person who would totally ask you for this top angle and not this angle. Let's see if they do. They say G, D, E, D, G, E. Oh, yeah, they totally asked for that one. All right, so this entire angle adds up to how much? All of this is 90 degrees. So 90 minus that 27. So 90 minus 27, and this top angle right here would have to be 63. So if that's 63, that's the answer they wanted, 63. All right, and this one down here, 14. Okay, so 14, look at those two angles. They say a rhombus. Don't overthink this. So because it's a rhombus, look at your picture. On a rhombus, that looks like this thing right here. These two angles, they're definitely equal because the diagonals bisect the angles. So here's the diagonal. It cut this angle in half. These two are equal to each other. So 9x minus 43 is equal to 5x plus 1, and then you just solve. So I'm just subtracting 5x, add 43, divide by 4. X equals 11. All right. Now, are you done? No, you have to plug it back in. So plug it back into here. I'll show my calculator. 9 times 11 minus 43. Oops. This right here is 56. Right here, 5 times 11 plus 1, that's also 56. Now, what did they ask for? They asked for V. So down here, they said SVU. So they wanted the whole thing, all of that. So if we look at our notes here, all these angles are the same. So if that's 56, 56, this is 56, this is 56. I want the whole thing because SVU. So 56 plus 56, we get 112 is the whole shebang, and that's what they wanted. 112. All right. All right, doing pretty good so far. All right, let's flip to the next page. All right, flipping to the next page. Oh, I like these. All right, so they just want to know if this is symmetric, right? So when will it land on itself? So if I reflect it, would it look like the same picture? Let's see. Okay, so this is reflection over the y-axis. Here's a y-axis. Does that cut that sucker in half? Yes, it does. All right, this one right here. We'll skip that for a second. This right here, that is y, that's this line right here. All right. All right, so you see that line? Does that cut that in half? No, it does not, so that doesn't work. Okay, we'll skip that one. Okay, skip. Okay, so now these three. So it's definitely this one so far. We don't know about those. If you look at your Hot Topics, at the bottom left corner of your Hot Topics, right here, it says, okay, we want it needs to be multiples of the regular exterior. So regular exterior equals 360 over n, because which we got up here. Regular exterior is 360 over n. Right. So 360, how many sides does this have? 1, 2, 3, 4, 5, 6. Or you can count the angles. 1, 2, 3, 4, 5, 6. So over 6. 360 divided by 6, and you get 60. So we want multiples of 60. So that would be, so in my calculator, okay, that's 60 plus 60, which is 120, plus 60, which is 180, plus 60, 240, 300, 360. And once it gets to 360, it starts repeating itself, right? Okay, so in that list, was 160 on that list? No, it was not, so that doesn't work. Was 60 on that list? Yes, it is. And is 240 on the list? Yes, it is. So those are the answers. Those, all three of them are possible, are the answers. All right, next one. Now we're gonna get into real fast stuff. All right, so here is the center. I know it's kind of hard to see sometimes, so I'm just gonna highlight that. Hopefully it'll pop out just a little better for you. All right, so there's my center. All right, let's go ahead and plot the points here. We have A is at 2, 1, 2, positive 1. And 1, 2, 3, 4, 1, 2, 3, 4. That's my B. All right, so there's my A, there's my B. All right, and then, okay, now C, D. So they're asking, hey, what's the slope of BC? So if you had a square like this, A, B, C, D. All right, these have to be perpendicular. They're perpendicular. That means that the slopes have to be perpendicular. That means that they have to be negative reciprocal. So basically, you have to flip the sign and flip the fraction. That's the rule. So for example, if I had, I don't know, making something up, 4 over 5, so positive 4 over 5, the perpendicular slope would be negative 5 over 4. So we have to look at the slope that we have right now. This slope at this moment, see the right triangle I'm making? All right, first of all, is this a positive or negative? Where this is positive, this is negative. Is this a positive slope or negative? That's a positive slope. And that rises 3 over 2. So what would be the perpendicular slope? Just flip it. So flip the sign, that's negative. Flip the fraction, that'd be 2 over 3, and that's the answer. So isn't that nice? Now, something else that could happen is, let's see. Something else that could totally happen is this silliness right here. All right, so I wonder if I'm going to do that later. 3, 2, 4, 4. Yeah, something else that could totally happen, which I think it happens on the Hot Topics. The booster. It totally happens on the booster. Is this? So if I give you A and C, we want this B and D. They have to cut across. It can't be down here because if you had this square right here, it wouldn't go in a circle. It would be A, B, D, then C. See, A, B, D, and C, it doesn't go in a circle, right? So you would have to have these 2 points here and here. So you'd have to find the middle. So this is us finding the middle. Boop. And then you see how to get from this point, from the center to here, that is, I went up 2 over 1. So if I went up 2 over 1, the perpendicular slope would go down 1 over 2. So I went down 1 over 2. And that would be that point. And just undo that pattern and you would find the other one. So that's how that works. So you would have to find the perpendicular slope. You'd have to find the middle of the diagonal, then figure out the slope and do the undo. So that was just a random example. Anyway, number 17. All right, number 17. To help us out, I'm going to go ahead and darken the axis lines just to let it pop out a little better. Let's plot the points. We have 0, 0 is A. We have 1, 2, 3, 4, 5, positive 2. That's your B. So this is A. This is B. 1, 2, 3, 4, 5, 6. Positive 5. 1, 2, 3, 4, 5. There's my C. All right, so if we connect these, so there's A, B, C, and we're looking for D. Okay, to find D, the quickest way is, you see this, D has to be somewhere over here. So I'm trying to figure out what this pattern is right here. So this pattern, I went over 1 and I went up 3. So I went over 1, up 3, just do the same pattern. Over 1, up 3. So over 1, up 3, 1, 2, 3, and that will be my D. So whatever pattern I had here, I do the same thing, and that's my answer. Now, where's that coordinate? That is 1, comma, 1, 2, 3. And that's it. And now if I asked for the coordinate, that's the answer. If I asked for the x coordinate, that would be 1. If I asked for the y coordinate, that would be 3. But in this case, they wanted the full-on coordinate, so this is the answer. Just be aware that this is a silliness that I would totally ask for, that I would totally mess with you on. So be careful. Sweet. Number 8. Okay, I'm going to highlight the center here so it pops out just a little better. We have negative 5, 1, 2, 3, 4, 5, positive 6, 1, 2, 3, 4, 5, 6. There's my A. Positive 6, 1, 2, 3, 4, 5, 6. Positive 6, 1, 2, 3, 4, 5, 6. There's my B. We have positive 8, 1, 2, 3, 4, 5, 6, 7, 8. Negative 3, 1, 2, 3. There's my C. And negative 3, negative 3. There's my D. All right, if I connect the dots. All right, what's the name of that shape? Now, if I used a straight edge, I'd be safer. So looking at this, pretty sure this is a parallelogram. I know that these two are definitely parallel. This one, how did I get from here to here? I went down 1, 2, 3, 4, 5, 6, 7, 8, 9. I went down 9 over 2. If this has the same pattern, I'm good. If I go down 9 over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 2. Yep. So all these are parallel. So that's parallel, that's parallel. That's a parallelogram. Okay. Wait, please. Okay, I'm going to plot the points. Shing, shing. We have 1, 1. We have negative 2, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 1. 1, 1. That's M. Negative 2, 5. That's A. That's T. And that's H. Awesome. Boom, 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 boom. Okay, so here's our shape. And what kind of shape is that? Let's see. Those definitely parallel. That is 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. Okay, so that's definitely a parallelogram. However, these look the same, don't they? Let's check. Like this one, yeah, I could tell that those are not the same distance, because if I measured it, see this distance right here? That's definitely not equal, right? Okay, but however, on this one, these pretty much look the same, don't they? This and this, yeah, that's pretty much equal to each other. So I'm pretty sure this is a rhombus because all the sides are equal, but let's double check. 1, 2, 3, 4, 5. That's definitely 5. Okay, and then this is a 3 by 4. All right, so if I do 3 squared plus 4 squared equals x squared, that's 9 plus 16. That's 25 equals x squared. I square both sides, I get 5 equals x. So yeah, that's definitely 5 as well. So that is a rhombus. So rhombus, because all the sides are equal. Sweet. All right, this one right here. Diagonals of a quadrilateral are congruent. All right, so we're trying to figure out what these shapes are. All right, I'm going to grab my hot topics, which is right here. All right, so they said, all right, diagonals of a quadrilateral are congruent. So where, so the diagonals have to be congruent. Diagonals. So diagonals congruent. All right, let's just put equal sign. So diagonals are equal, but they don't bisect each other. Diagonals not bisect. Okay, what is the shape? Okay, so let's look at our options. They said isosceles trapezoid. Okay, so if we look at the isosceles trapezoid, all right, does this and this equal? Yes. Does this and this not bisect? Does this and this equal each other? No, they don't. So that means that they don't bisect. So far, so good. This one works. All right, parallelogram. Okay, does this, see it's triple, triple? Does that equal a 4, 4? Does 3, 3 equal 4, 4? No, it does not. So it's definitely not that one because diagonals have to be equal, right? Rectangle. Does a 3, 3 equal a 3, 3? Yep. And plus it says that diagonals are congruent. So that works. So sorry. So far so good, but but they're not supposed to bisect. Does this? So this one worked for both of them. This one worked for the first one. However, it's see how these two are equal? That means that they did bisect. So it didn't work out for the second part. And a rhombus. Here we go for a rhombus. Does this equal this? Nope. So the only thing that worked was A. So the only one that worked is A. Which statement is false? All right, parallelograms or quadrilaterals? All right, here's a parallelogram. Is that a quadrilateral? Is that a four-sided shape? Yes, it is. Rectangles. Here are rectangles. Are rectangles parallelograms? Yes, they are. Squares. Are squares rhombuses? Yep, all the rhombus rules. So that works. And then rectangles are squares. All right, so look at this rectangle. Is that a square? No. However, a square can be a rectangle, but a rectangle is not a square. So this was the X, and they wanted the false, so the answer was D. All right, this one right here. All right, best thing you do is just label as you go. All right, so no idea what's going on, but they said this is a parallelogram. Okay, cool. BC is equal to AD. Okay, as soon as they say things are equal, mark it. AB, that's a double, is equal to DC. Mark that. AC, that's this whole thing, is equal to CA. So 1, 2, 3. And this triangle is equal to this triangle because of side, side, side. And then why would these two angles be equal to each other? So if there's a step after side, 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 it's automatically CPCTC. And that's this, CPCTC, CPCTC. So boop, the answer was C. Ooh, we're on our last one. Okay, here we go. No idea what's going on. We're just going to label as we go. Let's see. So I know for a fact that the last thing I'm ever going to do is what I was trying to prove. So that goes here. So triangle ABE is equal to triangle CDE. That's always the last thing. What you're trying to prove is always the last step. The reason is just up there. So that would be E. They also said that DE, okay, so let's mark it, is equal to EB. No idea why. I do, but you probably don't. Let's see. We also know that AB, boop, boop, is equal to DC. And also, what was the given? All right, so let's backtrack here. So I'm just marking things. Anytime they say something's equal, just mark it. No idea what's going on. Let's just do it. All right, given, we know that ABCD is a parallelogram because that's what this is. And that one was this one right here. That's C. Next, so why would AB be equal to DC? Why would AB be equal to DC? So just look at this, and it had to do with something that you just said a second ago. So let's see, what kind of things are these? What's AB? That's definitely a side, right? So let's see, In a parallelogram, so AE is, no, that does, so it can't be A, definitely not. In a parallelogram, opposite sides are congruent or diagonals bisect each other. Okay, this is definitely not a diagonal, so the only thing that worked was B. So B is the only thing that works, which is opposite sides are congruent, because that's what you're saying. This side equal, the opposite side of this is equal to each other. Next, in a parallelogram, diagonals bisect each other. All right, diagonals bisect each other. That means things are going to be equal. So that AE is equal to CE. That's the only thing that works. 1, 2, 3. 1, 2, 3. So AE equals CE. That was A. We already did this one. So the only thing that left is D. Okay, why is DE equal to EB? What is this? That's a diagonal. Oh, look, diagonal bisect each other. Diagonal bisect. So that is D. And those are your answers. And we just faked it. And other than that, have a great and wonderful day. Hope that helped you guys out. Good luck.